We went to a tire swing. After we got there, Kyla got on the swing, and we realized that after 2.2 seconds, the tire had gone from 0 feet to 8 feet, back to 0 feet. More if you'd like.
Go ahead.
Okay, so we're going to label the y-axis D and feet. And the x is time in seconds. And it was 8 feet was the farthest distance away. And it took 2.2 seconds for it to do a cycle. So we started at 0 and ended at 0. And then it went up to 8. And then second cycle would be 4.4 seconds.
What?
And then we have to draw the sexy sinusoidal curves because she's beautiful. And the arrows because it goes on forever.
When writing the equation, you need to make it equal to d because we're measuring distance. And to start, you put a 4 because it's halfway between 8 and 0, and it's the vertical displacement. And you're subtracting 4 cosine because 4 is the amplitude, because our cosine wave starts at the bottom instead of at the top, because it's sad. And we know it's a cosine because it starts at the bottom and ends at the bottom for one complete cycle. And to get the b value, you have to divide 2 pi by the period, which was 2.2 seconds, and that gives you 10 pi over 11. What?
I forgot the point too.
I did?
No, I did.
Oh. And lastly, it's t instead of x because you're measuring time. How far will Kyla have traveled on the tire swing after 1.8 seconds?
Well, we'll just plug this in here. Clear that out. 4 minus 4 cosine. They're spooning 10 pi over 11 1.8.
Oh, and then to check our answer, we got to do the old DDD factors. So we go to about 1.8 on our graph, and then we go DDDDD all the way down to the x-axis. And then to check our answer, we our way over to the y-axis, which looks to be about 2.3 feet. And there you go.
How long had Kyla been on the tire swing after it had traveled for 6 feet?
So we go to the y-axis and mark 6 feet, and then we DDD our way over to our sexy sinusoidal curves, and then we DDD all the way down to the x-axis, and then we just, I don't know, we're eyeballing it, so it's about 0.73 seconds, and then we keep going again with our DDDDDDDs, and then we go back down to the x-axis again.
No one's DDDing.
DDD too, you know.
And then you see that that's about 1.47. And then we have one more answer to do, so we DDDDDDD again. And then we DDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDDD down to the x-axis, and we see that's about 2.93.
After 3.7 seconds, Kyla fell off the tire swing into a mud puddle. How far had she gone before this, or until this happened?
We mark 3.7 seconds on our x-axis. And then we're gonna do one final marathon of DDDing. DDD. And then one more over to the y-axis, and it's a D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-D-
Yeah.
Alright. So, you guys might be wondering what I'm doing right now, but actually, I'm creating a sinusoidal wave right now as we speak. And this light right here, the light waves, those are sinusoidal functions. My voice that you're hearing right now, also a sinusoidal function. Heart monitors are sinusoidal functions. Not funny. Sinusoidal functions, they're serious business. The medical field uses them all the time, and it's very important that they're accurate. So, yeah.